physics is like magic. You can never be certain about anything. There will always be some kind of uncertainty. For example, if you measure the length of a pen and you say it's like 14 centimeter, you can never be certain whether it's a little bit more or a little bit less than 14 centimeter because scale is measured in millimeter. But sometimes people confuse this with error, but uncertainty is not error. Let me show you. Suppose you have a dartboard. Okay. Now we have I'll take a green one here and the red one there. Now the red one, you know where it is. So you know how far it is from the expected value. That is error. And the green one, you know it's on the board somewhere, but you do not know how, because you can't see it. You don't know how it is, how far it is from the expected value. So there is some doubt over here. This estimated range of doubt. That is what uncertainty is. So because there's something that won't let you where your measured value is away from the expected value, that creates the uncertainty. It happens because of mainly two things. One is the reading limitation. That means whoever or whatever takes the reading has some limitation. The other one is instrumental limitation. For example, the scale, the resolution was 1 millimeter and it cannot measure something less than 1 millimeter. So let's go into the detail. I already wrote the stuff that we require. Now, uncertainty are mainly of because before we study uncertainty, we need to know what reading and measurement is. Reading is values from a single judgment. Now, what does that mean? See, suppose you're using a thermometer. The bottom, there is no reading at the bottom. You only take the reading at the top, right? And that's what a single judgment is. So the example can be thermometer. And the measurement is when two values are important, the top value and the bottom value, and you subtract them to get the value. For example, when you take the reading with a scale, you have to see the value at the bottom and again the value at the top. So there are two judgments, and that is measurement. Now, uncertainty is expressed in mainly three ways. First one is absolute uncertainty. Absolute uncertainty means how uncertain your measurement is. Now, this is represented by del x. If the value is x, we write x plus minus del x. That is del x is the absolute uncertainty, and the significant figure must be 1. Sometimes you can write this as 2, but please try to make it 1 because that's the rule. Now, how do you measure the absolute uncertainty? There are a few ways. For example, when you are using a reading, for example, thermometer, it's half of the smallest division. Because if you are taking the reading at suppose 75 degrees Celsius and the minimum measurement is 1 degree, so you can expect it should lie between 74.5 or 75.5. So your judgment can be half of one smallest division away. Now, measurement, you have two judgments. For example, the scale. So that's why your judgments can be away from the proper reading in both the places. And both the places by plus minus half. So that is why when you do the measurement, it's one smallest division. So for thermometer, half smallest division, and for measurement, it's one smallest division because you're adding these two half. So they're not that separated, they're actually related. Now, sometimes in experiment, you take repeat data. For example, suppose you're measuring a length, and the length came as suppose 10 then 12, then 1 time 14 meter. Then you take the range. Range is the highest minus lowest value. So over here, this will be, for the range will be 14 minus 10, that is 4. And then you take the half of the range. So over here, del x will be 2. If you think, you'll understand. For example, suppose the average height in the class is 5.5 and the maximum value someone has is suppose 6 feet, the minimum value is suppose 5 feet. So whatever, so the range is 6 minus 5, 1 feet. And the whatever value you say or whatever height you pick, it from 5.5 it cannot be lower than 5 or more than 6. So basically it's half of the range. Now if you use a digital reading, for example a electronic balance, then it's the last significant digit. For example, you got 28.3 gram in electronic balance. So measurement, you assume the error is 0.1. Okay, so let's write 0.1. So you can see this also in one significant figure. So remember two things: the absolute uncertainty that has the same unit as the measurement, and you represent this with one significant figure. Now the other way you can represent this is with a fractional uncertainty. Fractional is you basically, it shows how, what is the ratio of the uncertainty, absolute uncertainty and the measured value, or how uncertain your value is compared to the measurement. So you know the del x is the absolute uncertainty, it divided by the measured value. Then we have percentage uncertainty. This is basically you represent the fractional uncertainty with a percentage. So you multiply the fraction by 100%. Now, why do we need these three uncertainties? Because in different equations or different operations, we have different physical quantities involved. And sometimes they have the same unit, sometimes they're same, and sometimes they're different. And that is why for different operations we have to use different uncertainties. For example, when you add or subtract data, for example, you are let's look at this example over here. Suppose you want to find the length of this part, okay? So what we do is you take the diameter of the bigger disc, and then you can measure, suppose you're measuring up to this, okay? Or if you want, what you can do is you want to measure the diameter of the smaller circle, okay? So you take the reading from the top and then you take the reading of the bottom part of the smaller circle. And when you subtract them, you get the diameter of the circle. And suppose the bigger one was, the top one was 15 millimeter and the smaller one is suppose 10 millimeter. And both of them have 0.01 millimeter absolute uncertainty. So you have to subtract them to get this diameter, right? Now uncertainties or errors will be added. You don't cancel away, right? Because you're making mistakes and they add up. It's not like two minuses will make a plus. So you add when you find the absolute uncertainty, you just add them, okay? So we have, suppose we are finding the diameter. So del D will be 0. plus 0.1 equal to 0.2. Let me just write this properly. So del D will be 0.2 and D was 15 minus 10, that is 5 millimeter. Okay, so you can represent this by 5 plus minus 0.2 millimeter. You see this in one significant figure and they have the same unit. And again, in some equations, you have multiplication. For example, F equal to ma, or you may have S equal to Vt, so distance equal to velocity time. And suppose the acceleration, the value is 9.8 and the uncertainty was 0.1. The mass is 20 kg and uncertainty was 0.01 kg. Now, when you are this M and A, they have different units, right? Kg, the other one is meter per second square. So you cannot add the uncertainties. You're making, these are in two physical quantities, but you cannot add them because they don't have the same unit. You can only do similar things. You cannot add a mass and acceleration. So what you do is you get rid of the unit. So you find out the fractional uncertainties del A by A and del M by M, and then you get the total percentage uncertainty. So when you are multiplying, and then you use the percentage uncertainties. Okay. So for adding, subtracting, we add the absolute uncertainties, and for multiplication, you add percentage uncertainties. The other one we are going to discuss is power. Sometimes in equation you have power. For example, you have S equal to ut plus half of at square. Now, if u equal to 0 or initial velocity is 0, this becomes s equal to half of at square. Now, if you look at at square, we can write as t into t. We already know how to do it, what to do with a and t. You just add the percentage uncertainties. But when you simplify this as a into t, so we can write this as this, right? Del a by a plus del t by t plus del t by t. Now, this part can be written as 2 into del t by t into 100%. So that is how we simplify the work when we have a power. We multiply the uncertainty by the power. So here we are multiplying the percentage uncertainty by 2. Basically, that is all you have to know about uncertainty. Soon I'll post a video on how to how to solve some problems. Till that time, see you.